Okay, so yes, so we'll continue with from where we stopped in the last class. Now we'll go for the next problem. Okay, so we were looking at problems which in which the true shape will be given. Okay, we have to find how the cutting plane has to be placed and how to get that particular true shape that is needed. Right. Okay. So the next problem over here in this type of methodologies is the next problem where we have a tetrahedron edges 70 long is lying on HP, okay, on one of its faces. So there's a tetrahedron whose edge is 70 long. It is cut by an inclined section plane so that, okay, now we are going to cut that tetrahedron, okay, by a sectioning plane, okay, so that the true shape of the section is an isosceles triangle. Okay, after cutting, okay, where we have cut onto the tetrahedron, it should look like a isosceles triangle in the cut portion, okay, whose base is 50 and altitude is 40 Find the inclination of the section plane with HP, draw the front view, sectional top view, and true shape of the section. Right. So after cutting, the true shape on the cut portion of the solid should be a isosceles triangle. Okay. How should we place the tetrahedron? Not given. Right. What is the cutting plane angle? How does it pass, or what height does it pass from the axis of the solid? No, not given. Right. So we have to find out this. Now for what do we need? We need an isosceles triangle. Okay, we need an isosceles triangle. Okay, now how to get that? Okay, for an isosceles triangle, what do we need? Right, let me draw the xy line. Okay, yes. Okay, now if I have a tetrahedron, let me just draw a rough diagram. Okay, and from here, okay, now this is a tetrahedron, right? Okay, now if I cut in this particular portion, I should be able to get, okay, I should be able to get what? I should be able to get a, see, along this, if I take off this particular portion, okay, I must be able to get a triangle. So if, say for example, okay, now let me name it so that you will be able to understand. So if we have here A, B, C, which is the base of the tetrahedron, and here let me give the name D, okay, right, which is the apex of the tetrahedron. Now on this, we have one slant edge from A to D, B to D, C to D, okay. Now, if I need a triangle, what should I have after cutting? If I need a triangle, it should be something like this. I'll just draw it a little bit darker, so and with a different color. So like this. So that means the cutting plane should pass in this particular manner. Right? So just look at this red color triangle that I've drawn. We have 3 corners, and each of these corners is passing on the slant edges of the tetrahedron. Okay, A to D, then B to D, and C to D. On all these 3 slant edges, we have one corner of the triangle. Okay, so we should keep the triangle in such a manner. So the edge length of the tetrahedron is how much? 70 Okay. So in the top view, it's going to appear as a as an equilateral triangle. Yes or no? Okay, all right. So find the center of this triangle in the top view that we have drawn, because we have to draw a tetrahedron, right? Okay. Now project it to the front view. From here, once again, here, and from here, okay, let it be as it is. Okay, right. Yes. Yes, can anyone tell me how we are going to finish the tetrahedron in the front view? Hello? Anyone? How are you going to finish the tetrahedron in the front view? So this is going to be the axis and slant edge. So from here, what we are going to do is arc by center. So that where we have A to O, which should be a line, slant edge should be parallel to XY line. So from that particular base corner, take the length of the tetrahedron, which is 70 mm in this case, cut it so that it cuts the axis line. Okay, it cuts the axis line. Now you connect this to the corners of the tetrahedron. That is the base of the tetrahedron. Right, so this will trim it off, not required. Okay, and this one is going to be the axis, sorry, this is going to be the axis line. Okay, let it be as it is. Okay, let me darken it, no problem. And okay, and since it's a tetrahedron, okay, the top view will appear like this before cutting. Okay, before cutting. So here we'll have A dash. Here we'll have B dash. C dash will not be seen, it will be hidden because it is backside. Here we have O dash, and at the base here we have O1 dash. Okay. Right. Now what are we supposed to do? The base side of the tetrahedron, sorry, the triangle, true shape of the triangle that we get should be having what? the base should be, this particular length should be 50 mm what he's saying. And then the distance from here to this corner should be 50 mm. That is the altitude of the true shape of the triangle should be 40 mm. Okay, so if this has to be 50 mm, see here this particular line is parallel to the base edge BC, right? So we have to draw a line for 50 mm. Okay, right? So just like the same last time what we did. Okay, right. Now with keeping this as 50 mm, okay, such that it is going to be there on the slant edges of the tetrahedron. Okay, right. Now keeping with this, what we will do is, keeping only with this. Okay, now we'll project this to the front view. Okay, from there further on extend it. Okay, we can extend it. It's going to meet here, right? Now from here, this altitude, that is the height of the triangle, should be 40 mm, right? 40 mm. So what you do is go to arc by center, keeping this intersection point, okay, as the center. Okay, radius should be height of the triangle that is required, that is 40 mm. Cut the opposite edge. Okay, cut it here. Okay, now join this. Here. Now let me extend it. I'll go to extend to next. Let me extend it. Okay, it's coming too close. Let's see. Which line did I extend? Yes. Okay, so this particular line is going to be the cutting plane. Okay, and now what I'll do is I'll split it here so that whatever the portion that is going to be retained and the portion that is not going to be retained. So this portion is not going to be retained. And similarly here also, let us split it up. And this is going to be like this. Right? Okay. Now after getting this, what are we here? We have one point of intersection, nothing but the cutting plane meets the slant edge of the solid. So point number 1 dash. Okay, here we have two slant edges, B dash to O dash, C dash to O dash. That means 2 point of intersections we are getting. So one is 2 dash and the other one is 3 dash, which will be hidden. Right. Now project this 1 dash point of intersection to the top view. Project this 1 dash point of intersection to the top view. Till it meets the line AO in top view. Now connect this. Okay, now going to this, what is going to happen? This line is going to be dark. Okay, and here this particular portion, again this particular line, and here will be, we can delete it off, and this will be hatched. Okay, and here also okay. Now after getting this, they've asked us to find the section plane angle. So we can just draw one small line if at all we need, or when you're writing it on your sketchbook, you can just measure it with your protractor. So I'll just show you the angle between the XY line, or else even this is not required. We can show it from here itself, from XY line to the cutting plane. The angle is going to be 63 degrees. Now let's go to offset. We'll offset this. Okay, right? Project it from 1 dash to the x1, y1 line, and similarly from 2 dash something is wrong. Okay, I'll just move this itself. So from here, what we are going to do is the next step. So we have to measure the distances of point 1, 2, 3 from the XY line. So let us mark the points. 1 is here, 2 is here, and 3 we have it here. 3 is here. Okay. Okay, now let us measure these distances. So one is 55.3, the other one is 80.16, and then the other one is 30.16. These are the distances at which they are. Right. So now, yeah, 1 minute. Yeah. So yes, so what is line number 1? How much it is? 55.13. Okay. So 55.13, isn't it? 55.13 at an angle of. Okay, and this one, what is the distance? Point number 2, 80.16. 80.16 from here. 80.16. And another line from here only is how much? 30.16. Okay. Yes, now join all these things. Fill this. Yes, what should be the length of the equilateral triangle? Sorry, of the isosceles triangle, it should be 50 mm. Okay, what they are asking is, we want this distance. We want this distance. Okay, let me do it. Just a bit. This should be exactly 40 mm. Why? Because here we have taken 40 mm as the radius, okay, to cut this. So here also you will get automatically 40 mm. There's some light mistake where it is not joined over here. That is why I'm getting this 39.81. Okay, please do it correctly on the sketchbook or on a sheet of paper. You will get it over here as 40 because to draw this sectioning plane from 2 dash to 1 dash, you will have taken 40 mm as the radius, and the same will be reflected here also. Okay, right. Yes, any doubts? Any doubts? Hmm? No doubts? Hello? 1 second. Yeah. No doubts? Okay, do this problem. Do this problem. I'll keep it. Do this problem. Over, huh? Finish drawing? Why today nobody is answering? Yeah. Okay, Rajat is doing it. What about others? Shubhankit Singh? Shubhankit Singh, are you there? Here we'll have x1 and we'll have y1. And trim this only. Here we can have x, y, vp, hp, all those things. Yeah, finish the timings for this also. So here we'll have one double dash, then two will be here, two double dash, and three double dash.
Sir,
Yes. Yes, tell me.
can you zoom out, sir?
Zoom out.
Sir, ಸ್ವಲ್ಪ sir, ಸ್ವಲ್ಪ sir. Yeah, yes, sir.
See, look here, all of you look here. 2 is at a distance in the top view. Point number 2 is at a distance of 80.16 from XY line. Okay, so similarly, when you name the two double dash, well, we draw the true shape of the section, it should be at a distance of 80.16. Okay, so don't forget that. So if you are getting confused, this is the easiest way to remember it. So don't get confused that whether I'll be having here two double dash or three double dash. So what is the distance over here? Accordingly, over here also you are transmitted. So transferred it. So accordingly only for that particular distance, what is the alpha number is being given here? The same number will be with double dash in the true shape of the section. Okay, is it over? Done? Yeah, shall we go to the next problem? All right. Okay, so let's go to the next problem. Okay. So we have done these problems. Okay. We've done this. We have done this also in the last class. Okay. Now we'll go to different problem. I mean a different procedure for. We have seen problems for prism or a cube. Then how to cut, how to find the number of cut point of intersections, and how to proceed with the problem. Then we have seen with special cases of problem where uh, they will give the true shape of the section, but we have to find out how we should cut the solid. Okay. Now, in the first type of problems, that is cutting, sectioning plane, cutting distance, angle, everything will be given. So we have seen only for a prism or a cube and for a pyramid, but we have not seen how to draw it for a cone. So now let us see how to do the same thing if we have a cone problem. Okay, why? Because for a cone we don't have any slant edges. Okay, sharp slant edges are not there. We have only generative surface, a very smooth surface. Okay, in the conical form we have. Okay, now how do we find cutting points on this surface where we don't have any slant edge at all? Right, so we will see that. Okay, so the problem over here, the problem that I've taken now is a cone whose base diameter is 60 mm and axis 70 mm. Okay, so diameter of the cone is 60 mm, height of the cone is 70 mm, stands vertically with its base on HP. Okay, that means the circular base is resting on HP. Okay, a section plane perpendicular to VP. Okay, now we have a section plane. Okay, perpendicular to VP. That means it has to move from the observer towards the wall or towards the vertical plane. Okay, we are cutting in that particular direction. Okay, right, and parallel to one of the end generators. One of the end generators, it has to be parallel. Okay, of the cone at a distance of 15 mm from it. Okay, so we have to understand what is this particular line. What is this? One of the end generators of the cone, okay, and passes at a distance of 15 mm from it. What does this mean? Unless and until we understand this, we cannot solve the problem. Okay, anyway, I'll explain this when I do the problem. Draw the sectional top view and the true shape of the section. Name the Name the curve of the true shape of the section. What type of curve we are able to get, name it, is what they are asking. Okay, right. So let us start drawing the problem. I'll just go to I'll just draw the XY line. Okay, now the cone diameter is how much? When the question given 60 mm. Okay, right. So for 60 mm, let me draw a circle. Diameter is 60. Okay, now the next thing is that, okay, now let me go to this, draw the projections. Okay, so yes, so let's draw this. And from here, the height of the cone is 70 mm, right? So for 70 mm, let me draw it. Okay, so here I can do is, if at all I want, I have to divide it into 8 or 12 equal parts. Let me keep it only 8. Okay, so I'll just go to rotate this particular thing for an angle of 8 equal parts, right? So 8 equal parts. Right, 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts. Let me project this one also to the front view. Okay, and from here, let me connect it to the apex of the cone. We need this. Okay, right. So let me give the namings. Okay, so here I have A, then B, here C, here D, E, F, G, H. Okay, so here I'll have A dash, and here I'll have B dash and H dash. Here we'll have C dash, and hidden will be G dash. Here we'll have D dash and F dash. Finally, E dash will have. You zoom in and let me fit it. So here I'll have E dash. Okay, yes. Now what is this line? Now this line, say for example, what is this line? B dash to O dash. Is it a visible edge? B dash to O dash. Is it a visible edge? Right? So for a cone, we don't have any sharp edges that is actually present. It's only a smooth surface. Okay, right? Okay, so these are nothing but B dash to O dash, A dash to O dash. Any namings that I have given is
Not
nothing.
edges.
Yeah, they are not the edges. They are only the imaginary lines that we draw, which we call it as the generators, and as the generators of the cone. So the one that is there at the end, A dash to O dash and E dash to O dash, is the end generator. Okay, these two are called as the end generators. Okay, right. Okay, now one more question I have. Is A dash O dash line, the length of this line A dash O dash, and C dash O dash, is it same? in the front view?
No, sir.
No. How about A dash O dash and B dash O dash?
No, sir. No, not same.
Why it is not same?
Sir, the A dash, O dash, distance is large.
Why is it not same?
It's the
It's
same,
the
sir.
same.
Yes, sir. Diameter is same, no,
Yeah,
sir. The
diameter
whole
same.
A dash
No,
O
I am
dash are
Sir,
talking
same.
in the
distance
front
varies,
view.
sir.
In the front
Distance
view,
varies.
see on the object it may be same, but in the front view is it same?
No, sir.
No, sir. B dash O dash is lesser than A
Why?
dash because the angle, sir.
Okay, B dash O dash, if you look at it, if you take B dash O dash is nothing but a line, right? So now, say for example, let me 1 second. Okay, B dash O dash, the line is now inclined to VP and HP, both sides like this. Okay, whereas A dash O dash is exactly parallel to the VP plane. So this is the A dash O dash is the true length of the end generator. This is the apparent length of the end generator. Is that clear?
Yes, sir.
Yes
Yes,
or
sir.
no? Right? So A dash O dash and E dash O dash is the true length of the generator. Whereas all the other generators that we have created is nothing but the apparent length because they are inclined to both HP as well as they are inclined to VP also. Okay, right? So remember this. This we have already studied in last semester projection of lines. Okay. Now, so what is end generator? We came to know. Now the cutting place passes through one of the end generators of the cone at a distance of 15 mm from it. So from the end generator, it should pass at a distance parallel to it at a distance of 15 mm. So what I'll do, 15 mm outside if I cut, what is the use? Any use? If I take it here, is it going to cut the solid? Hello? Will it cut the solid?
No, sir. No, sir.
No.
No,
So I
sir.
have to take it inside, 15 mm inside. Okay, see the distance? 15 mm inside. Okay, 15 mm inside. So I'll cut this. So this is going to be the sectioning plane. Let me extend it till here, till here. Okay, let me extend it. This line is the sectioning plane. Okay, right? The distance is 15 mm. Okay, right. Now, let us now see the point of intersections to mark the numbering. Okay, so on A dash O dash, there is one cutting point over here. So I'll give 1 dash. Here I have very close to that 2 dash. Okay, then on this axis, that means over here also we have one end generator. So here we have 3 dash. Okay, and here we will have at the bottom, it is cutting the base of the cone. So there is one circular surface. Now if you look at it, now, if you look at it, we have something in front curvature. At the back side also we have curvature. Okay. So for that, we'll have one cutting point in the front, one cutting point at the back side. Okay. So we'll have over here. Okay. I'll just mark it up over here as O dash in front. And at the back side, we'll have phi dash. Okay, now coming back, now going to the back side of the cone, front side of the cone, if we cut 1, 2, 3, 4, we are getting. Then next onto the back side of the cone, 5. Then at the same intersection point at the back side, we will have 6 dash. Then here we will have 7 dash. That's all. Because here it is only a one straight line, n generator, so only 1 point. Okay. Okay, so I'll just keep the points so that you can see where it is. So let me first split it up. So one is going to be here. Point number 2 will be at this intersection point 2 and 7. Then on point number 3 and 6 will be here at this intersection point. Okay, and 4 and 5 it will be here. Okay, so this and this portion is also going to be light. Yeah, so let me keep one dot so that you will see where it is exactly. I'll just change the color to red and it will be here 1, then 2 is going to be here, and 7 also, 3 and 6 will be here, 4 and 5 will be here. Okay, right? Now let me put this now only offset. I'll take this line, I'll offset it by 25, okay, 25 mm. Let me see. 25 is not enough, so I'll keep 35. Yes. Yeah. So at this distance, let us draw the x1 y1 line also. Okay. For time being, I'll keep it now here only. All right. Okay. So yes. So now let us go. Now what we have from these points 1, 2, 3, 4, 5, 6, and 7. Let us drop it to the top view because we have to show top view in section. So A dash O dash, and on this particular line we have point number 1, which is going to be what? Which we have to transfer it to the top view. So this is on true length. So no issue with this. Okay, we can directly draw the line. We can directly drop it down. Okay, not a problem at all. Until where we should go? It should go until it meets the same respective line onto in the top view. So where we should stop? We should stop on AO. Okay. Right. Now what about point number 2, which is on line B dash O dash? Which is on line B dash O dash. Is it a true length line? This B dash O dash?
Apparently.
Apparent length. So any measurement from this should not be transferred to the other view. It is not the correct one. So first we have to transfer this point to the true length line. Okay, just draw a horizontal line to that because we have to know the exact height. Okay, right? Exact height. We have to transfer this point to the true length line. And now from here also, yeah, so this here, let me give the point 2, 1 dash. Okay, 2, what shall I give? This is the actual one. Okay, let me give it as just near numbers only. This should be 3 as well as for 6 also. Okay, for both. Okay. Three comma six I'll put. And here I will have 2 comma 7. Yeah, right. So now from here I will drop it down. From here I will drop it down. Okay, where is point number 2 and 7? Point number 2 is on B dash H dash, right? So for that I'll go here until it meets this particular line. See, on BOHO. Okay, and similarly for point number 3 and 6. Okay, for point number 3 and 6 is what we have to do a little bit circus. We'll see that. Where's that line? Where did it change? So from here, okay, so this is where this is on AO, right? So on AO, correct? So 1 second, on AO, correct. All right. So actually we should stop these lines only on the AO line only. We have to stop it here only, and even this also, I made a mistake. So I'll just show you the interpretation. So this is point number for 2, this is for point number 3. Okay, now keeping this as the center. Now after getting this line should, this point number 2 should be aware on actually B2O and H2O. Point number 3 should be on C2O and G2H, sorry, G2O, right? So for that, what we'll do now is that go to arc by center, keeping the center of the circle, and this particular line, the line that we dropped from number 2, okay, as the radius, cut an arc. Okay, cut an arc. So see, where is it cutting? I'll just show you. See, point number 2 is actually going up to here. It is going to meet at this intersection point. Okay, and similarly on the line HO, it is going to be intersecting here. Okay, now coming to the question, why did we do this? Now if I tell you for point number 3, see, point number 3 is at some particular height, which we don't know the true height. Okay, now when I drop it down directly, where is point number 3? On C dash O dash. Okay, so on C dash O dash, this line, where will you cut? At what distance? Should I cut here or here if I drop it down directly, or here or here? Where? How do you know the distance? Did you get it? Anywhere that I cut is on C2O only, right? So to get that exact distance only, we transfer that height to the true length of the end generator and drop it down, and then from there Anyway, the cone is a circular in shape, right? It has got a smooth surface. So we are going to draw the arc. Okay, we are going to draw the arc. So from here, again from the center, from here up to point number 3 is going to be this. And get this onto the other side, that is other half of the cone also, right? So now I have to join these points. Okay, now I have to join these points carefully. Let me trim this. Okay, now where do I have? See, I'll just place it. So this is point number 2, this is for point number 3. So I will have the same points 3, okay, coming up over here and here also. So 3 and 7 will be here. 3 and 7. Okay, and here we will have 6. Here we will have 2, and here we will have 1. So just look at this. Sorry, 1 minute. 1, 2, 3. Okay, 4 I should drop. I have not dropped 4. It is directly cutting from, it is cutting at the base. Okay, so it is going to cut the entire base till here. Okay, so this cutting point will be number 4. Okay, this cutting point will be number 5. Here we'll have 5. Okay, and let me see what is the number. It is, sorry, this should be, it is 3 and it is what? 3 and 6. Oh, right. So from 3 we'll have 3 and 6. So from the line 3, it is 3 and 6. So this should be 6, and this is going to be 2 and 7 then. So now look at this. 1, 2. I'll just make it a little bit smaller. So now look at this. 1, so this line 1, and here we have 2, 3, 4, 5, then 6, and then on this arc 7 and close. Okay, so the first thing that we have to do when we do it on the system, okay, what we can do is we can keep points. Okay, the first thing that we can do is we can keep a point exactly at this intersection places. 1, then 2, and then 3, and here on this intersection we have 4, and here we have 5, here we have 6, we have 7 over here, right? So now we can connect it by a curve. So join all these points, okay, you should be able to get a smooth curve. From this, yes. Now we can join it by a line over here, from here to okay. Now hatch these portions. So let me split this circle. to split the circle, right? Okay, sorry, split this particular point, and again another split this particular point. Yeah, so that this portion of the arc is yeah, right. So this we will have, sorry, this we should fill. Right. Okay. Now going back to this, now we'll project these things to the true shape of the section. So before that, let us find the distances. Yeah, let us find the distance. So from what is the distance from here to XY line? This is for point number 1. Then for point number 2, where do we have? We have 2. 1 second. Yeah, 2 we have here. Yes, point number 3. Small thing that is over here. This is point number 3. Okay, and then yes, point number 4. We'll take point number 4. This point number 4. Okay, point number 5 will be from right. This is the distance for point number 4. Point number 5 we'll see the 6, and we have 7, right? So from 7. Okay, so we have to transfer these things to the true length, for the true shape of the section. So let's go to the front view now. Okay. Okay, perpendicular to that, perpendicular to the x1, y1 line. Okay, let me go to move option. I just anyway need parallel lines. 2, 3, 4, and 5 here. Okay. Okay. All right. So now we shall draw the lines correctly. Okay. Right. So what is the line number 1? What is the distance for point number 1? Where is this? For 3, this is for. Sorry, this is another distance. This is not the one that we require. This is not required at all. Yeah, we want for point number 2, it was actually, we've got something else. Okay, so for point number 1, okay, the distance is 59.35. Yeah, 59.35. Okay, point number 2 and 7. Okay, 2 is at a distance of how much? 7, we have it here. Okay, we'll measure 2 and measure it correctly. So if you do these measurements on the sketchbook, it's easy. Take a scale, measure this line, that's all. It's very easy to do it on the sketchbook. Yeah. 66.11. All right. So from here, I need 66.11 at 23. It should be parallel, right? Okay, then what about point number 3? Point number 3 is at a distance of 75.71. Point number 3, 73.71 parallel line. Again, point number 4 is at what distance? Point number 4, 86.54. Yes, from here, 86.54, again a parallel line. Okay, right. So now next point number 5. Point number 5 is 32.54. Okay, so on the same line only, 32.54. Point number 6. Point number 6 is where? Point number 6 is here, 43.08. 43.08. Right, and point number 7 is at a distance of 52.7. 52.7. 52.7. Okay, so now let me first place the point so that it's easy for me to draw the curve. Okay, I'll keep it in red color. So one point is here, and another point is here. Third one, fourth one, fifth one, sixth one, seventh one. Okay, so now I'll go to curve, command drawing these points. Okay, and connect it here by a straight line. Okay, hatch this portion is your true shape that you're going to get onto the cone after cutting. Right? Okay, so let me name the points. So here I will have one double dash, and 2, right? Where is 2? 2 is far away, 66, right? So the far away point, that means this particular line here, it is going to be 2. Okay, so I will have 2 double dash over here, then 3 double dash, 4 double dash, 5 double dash, 6 double dash, and 7 double dash. And this will be the x1 y1 line. The height of the cone I have not mentioned. I mentioned the height of the cone also. Is 70. Right? This distance is 70. Yes, any doubts? Or you want me to repeat anything? Hello?
Sir, section.
Where? Section means so many sections are there. Where you want?
Sir, how to make sections?
In
He's
front view,
asking section plane, sir.
section plane, no?
Yes, sir.
Oh, yes, sir.
See, section plane, see this end generator, E dash, O dash is there, no? Right? So what he is
Yes, sir.
telling, he is telling cutting plane is parallel to this end generator, but it passes 15 mm from it. So what I'll do, I'll go to offset, select this end generator, okay, give 15 mm distance, and inside that I will cut. This is going to be parallel to, now just look at this angle, 66.8 degrees. Look at the angle of the cutting plane, 66.8 degrees. But it should be 15 mm parallel to it inside. Is that
Okay, sir.
clear?
Got
Right? So what you can do is you can draw when you're doing it on your sketchbook. What you can do is, see, I'll tell you, when you're doing it on your sketchbook, you can draw anywhere over here, okay, a small line, okay, which should be perpendicular. See, this angle should be perpendicular, or you should know how to draw perpendicular lines. Draw it for 15 mm, and from here draw perpendicular to this, you'll get another thing, right? Is that clear? Yes, any other doubts? Others? Any other doubts?
No, sir.
Right? Okay, so the new thing that you will get, see over here is one second. I'm just saving the drawing. So the new thing is that in this, see, for point number 1 and point number 4 and 5, there is no problem. We can directly drop it down. Not an issue at all. But for point number 2 and 7, for point number 3 and 6, we have to transfer it to the true length of the generator. That is the end generator, and from there we have to drop it down. But where is this true length? It is on AO. So when we drop this line, we should stop at AO only. We should stop at AO only. And from there, keeping the center of the circle in top view, and where we have stopped this projection line on AO, draw an arc. See this line. So until and unless it cuts the required uh, generator line that we have drawn in top view, right? We have made 8 equal divisions. No, to that respective division only we should stop. Is that clear? Any doubts? Any doubts? Hello? Any doubts?
No, sir.
Right?
No, sir.
Okay. Okay, draw this. Draw this. Start drawing this. I will zoom in. Okay. So that you can see it much more clear. Start drawing this. Yeah, can you see the screen clearly?
No, sir.
Not clear, huh?
Sir, can you zoom in only like the front view, sir? Later we'll ask for the circle. ಮತ್ತೆ project ಮಾಡಾದ್ಮೇಲೆ points ಗೊತ್ತಾಗಬೇಕು point to.
Okay, okay. Now?
Yes, sir.
Okay, yeah. So top view, first all of you draw the circle, divide it into 8 equal parts. Then go to front view, draw the axis of the cone for 70 mm. And then cut this by 15 mm inside. Okay, parallel to the one of the end generator. Okay.
Sir. Sir. Sir?
So shall I zoom out so that you can see the entire drawing?
Yes, sir.
Yes, sir.
Yes, sir.
ಫೋನ್ ಬಂತಪ್ಪ ನಾವು ಇಷ್ಟೊತ್ತು ಇಲ್ಲೇ ಇದ್ವಲ್ಲ ಫೇಮಸ್ ಫೋನ್ ತಂದೆ ಹುಷಾರಿಲ್ವಂತೆ ಓಡ್ತಾ ಮನೆಗೆ ಇವಾಗ ಮನೆಯಿಂದ ಫೋನ್ ಬಂತು. ಪಾಪ ಒಂದಾದ್ಮೇಲೆ ಒಂದು ಏನಾಗುತ್ತೆ.
Sir.
Okay. Illala, continue. Yes, over. Drawing is over. I'll zoom out so that you can see. I'll put this
It's a zoom out. Yes, sir. Yes.
portion so that you can see exactly what is happening. Especially here, see this line, red color line, okay, and this particular red color line, okay, from where we have to draw. This is very, very important. Otherwise, your entire problem will go wrong. Yes, finish drawing. The drawing completed.
No, sir.
Over. Drawing is over. Hello.
Yes, sir.
You'll finish it. Any doubts?
Yes, sir.
Any doubts? Shubhankit Singh. Shubhankit Singh. Banerjee, any doubts?
No, sir.
Hello.
Yes, sir.
Is the problem over?
Yes,
Or
sir.
you
Done,
have
sir.
any doubt?
No, sir.
Okay. All right. So okay. All right. So now let's go to the next thing. Okay. So yes, with this section of solids, most of the different types of problems I've covered. Okay. I want all these problems for you to practice, okay, and upload it in the Google Classroom, okay. On every sheet of paper, okay, write the question, then do the solution, write your name, USN number, batch, okay, right, and also write your page number and put your signature also, right? Okay, and I want all these things to be uploaded regularly from time to time, whatever the deadlines I'm giving, okay, within that into the Google Classroom, right? Orthographic projection, some of you have submitted, still some of you have not submitted it, right? And section of solids, okay, I'll be posting it in the Google Classroom. In that particular classwork assignment heading, you have to post your section of solids drawings also, right? Okay, I want all of you to do it on the I want you to do the drawing on a sheet of paper or in a sketchbook, whatever it is. Okay, right? If you have the system, start practicing it on your system also and save your drawings. Don't waste time, because this is only the beginning. Okay, if you don't understand these things, in the further on, it will be much more difficult, where you will not be able to understand. Okay, without the knowledge of this, it's very, very difficult to do it. Okay, right. Okay, right. So let me go to the next thing. Okay, we'll go to the next chapter. Okay, let me go to the next chapter. Okay, which is on threads. Okay, so how to draw a thread? How should we define a thread? Right. So we'll see that. Okay. So 1 second. Right. So here we have about the thread. Okay, so we have to understand certain terminologies or keywords that is generally used in when we see a thread. Okay, so what is a thread? A thread is a spiral groove that has been formed on a generally on a circular or a cylindrical surface, on a cylindrical surface. So what do we get over here? So first of all, before the thread is being formed, we have a diameter of that particular cylindrical surface, which is called as the nominal diameter. Okay, right? Okay, and then once the helical or spiral form is of shape is being taking place onto the cylindrical surface, an angle is going to be formed. Okay, an angle is going to be formed, which is called as the thread angle. Okay, in this V groove, Okay, to if we see over here, okay, I'll just zoom in this portion. If we take a cut section of this thread, see, it will look like a V groove. It will look like V shape, right? It will look in V shape. So whatever is this angle, right, is called as the, whatever is this angle, we will call as the thread angle. Right? Then what is the pitch? This you have already studied in physics, that the distance between the consecutive highest points in a wave or the lowest consecutive points, the distance between that is called as the pitch. Okay, so we need this. So the same thing, we have some high points over here, okay, or the low end points in a groove, right? So either measuring from the highest point to the next highest point, or from the lowest point to the next lowest point, we'll have the pitch of the thread. Okay, we'll have the pitch of the thread. This is very much important. Why do we need this? We need this, say for example, if you take a Bisleri water bottle cap, okay, and you put that cap, okay, onto another bottle, okay, you put it on another bottle, you put it on a Coca-Cola bottle or a 7-Up bottle, it may not suit, it will not get locked. If you turn the cap and you try to seal the bottle, it will not, because the thread formed, okay, the threads are being placed at different distance, okay, right? So thereby it will not match. So pitch is a very important factor in the threads. Okay, right. So apart from this, once this groove is being formed, what do we have? We have the uh, onto the upper end, we will have the uh, major diameter. Okay, we will have the major diameter. Okay, and here at the bottom, the lowest end of the groove is to the other side of the lowest groove, we will have the minor diameter, right? We'll have the minor diameter, right? So this is most important, okay, right? And all these threads will be at a equal distance. So now if we measure from this minor diameter line to major diameter, this will give me the height of the thread. Okay, this will give me the height of the thread. Okay, right? So these are all the some of the very important terminologies that is required for a thread. Right? Apart from this, we have, right, we have, just look at this, this slant surface of on the groove is called as the flank or the side of the thread, right? So when we take a cut section, we will be able to see something like this in V shape, right? In V shape, okay, right? Right. So these are all some of the terminologies that is required. Now the next thing is that threads can be formed on two different things. One is on a cylindrical surface. That means a thread is formed onto the outer side of that cylindrical surface, which is called as external thread. Okay. Now if we have a hollow hole that has been drilled and we want a thread inside, okay, then it is called as an internal thread. So internal thread we will generally see in a nut, and external thread on a bolt. Okay, on the, if the thread is facing onto the outer surface, external thread. If the thread is facing onto the internal surface, inside surfaces, then it is called as internal thread. Okay. Now apart from this, so these are some of the common terminologies that we require for thread. Now apart from this, we have different types of threads. Okay, we have different types of threads. We have Acme thread, ISO thread, buttress thread, okay, right? And so many other square threads, right? So how do we represent such drawings is what we are going to see now, okay? So now we shall go to the first way of one of the threads, how to draw a thread, okay, for the given standard format, okay, whatever is this, we'll see, okay. Now let me take up this. In V threads, we have different varieties, okay. So in V thread, we have something called as the, one of them is called as the Whitworth or thread or British standard thread. So every country is following different types of threads that is to be formed, okay. So ISO standard is different, Acme thread is different, they're all spiral in shape, but the height, the angle, okay, and the and other parameters will vary, right? So British standard thread, how it is going to be drawn. So to draw this thread, we should first have the pitch of the thread. If we have the pitch of the thread, okay, okay, and then the diameter pitch of the thread, then we can draw it easily, okay. Only with diameter we cannot do anything, okay. Either we should have diameter or pitch, okay. So for a British standard thread, what is there, okay. So for a British standard thread, diameter is equal to 0.96 times, okay, 0.96 times the pitch. If we have the pitch, then we can easily go in for the height of the thread or diameter of the thread, and all other calculations we can do. For a British standard thread, the angle between the adjacent sides of the flank, okay, or that V shape that is being formed will be at an angle of 55 degrees. Will be at an angle of 55 degrees, right? Okay, this we should remember. Okay, this we should remember. Okay, right. Now let us go to this. So for all the threads that we are going to draw, let us assume that the pitch is going to be 50 mm. Okay, assume pitch is equal to 50 mm. Okay, right. So based on this, we will do the drawing. Okay, for a British standard thread, what do we need? Height of the thread. Okay, we should know what should be the height of the thread if we have to maintain 55 degrees, and pitch, that is distance between the two highest consecutive points, should be 50 mm. Okay, so what should be the height of it? Height of it should be H or D. Okay, both are almost are same only, which is nothing but 0.96 times the pitch, that is into 50 mm. Okay, so we'll get height of the thread will be 48 mm. These calculations we have to do. We have to remember for a British thread what should be the conversion factor. How do we find the diameter or height of the thread? Okay, then to draw the thread, to get the curved features that you can see here in the image, okay, we have to have the curvature feature. So at what distance should it be? Okay, so that is given by, the next one is given by, okay, h by 6. Okay, where how much is that? How much is h? 48 mm into 48 mm divided by 6, that will be equal to 8 mm. This details we need. Okay, this, without this details we cannot do anything. Okay, without this details we cannot do anything. Okay, right. Now let us see how to draw the British standard thread. Okay, Now, how do we draw the British Standard thread? First thing is that we will draw one light line, one horizontal line. Let me draw it here. Okay, then let me draw another line offset at a height of, what is the height of the thread? 48 mm. So I'll offset this horizontal line at 48 mm above. Okay, right. Next, to draw the curved features, it should be at a distance of 8 mm. So I'll offset at 8 mm from the baseline. Offset by a distance of 8 mm from the baseline inside, and again from the top end also I will do it. Now next thing, I will draw one vertical line anywhere on this horizontal lines that I have drawn. Okay, angle of the thread should be how much? Angle of the thread should be 55 degrees. Okay, angle of the thread should be 55 degrees. That means half of this will be how much? 27.5. This angle should be 27.5 degrees. And I'll draw this vertical line from here also. We need this. I'll mirror this. And what I will do is that I'll take this, 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 plus this. I'll move it. Right? Now, let me zoom in. So let me put the dimensions over here so that you will know. This is 8 mm and this is another 8 mm. So now coming back over here to get the curved feature, okay, at the tip of the thread, okay, it is not going to be a sharp V edge, okay, it is going to be a slightly curved edge. Now look at this angle is going to be 55 degrees. Now to get this, from this intersection point, draw a line perpendicular. Draw a line perpendicular. Make it 90 degrees. I'll just zoom in this portion. Make it 90 degrees. 1 second. All right. All right. Yeah. Should be very, very careful with these drawings because very small changes will be there from one thread to another thread type. Okay, this angle is no more required. Okay, I have kept it as it is. Good match. Let us see. 1 second. Okay, sorry. We'll make it like this. Sorry. This should be 87.5 degrees. Okay, and this line should be parallel to this. Just move this line. here, take it exactly on this intersection. Okay, and I'll trim this. Now, keeping this as the center, this one as the radius, I'll draw the arc. Unless and until it forms a tangent. Or unless until it meets this. Okay. Now I'll mirror this feature to the other end also. Okay, right. Now the same thing should be repeated here also. So what I'll do is, I'll just take this, what I did here, the same procedure, I will do it to the other end also. Okay. Right. So, okay. So let me go to move option. Take this line, hold it here. Right. So now keeping the same procedure, I'll do here also. Keeping this as center, this one as the radius. I'll just draw this and mirror it onto the other side also. Right. So with this, what I can do now, I will go to split. I'll split this line at this particular point. Yes, and again I'll split this line over here. Then I'll go to split once again. Split here. This one here. Right. So I'll make these things dark. Okay. All right, so let this be split up over here. This line over here. So this particular arc should be dark. Right. So now having this, I can copy and replace these lines. Copy this. Okay, yeah. So now what I can do is, even if I don't have these lines, I can easily get everything. This, I'll just go to move, hold it here, place one over here, two over here, three over here. So now just look at it. The threads are being drawn. Threads are drawn, right? So I can just hatch these portions. Okay, which will be, so here wherever we are hatching, here we mean to say we have material in this particular place. See, if you are familiar with the tools and have the idea of how to draw, then it's very easy to do these threads. See, that's all is about threads. Okay, right? So this is for British Standard Thread. Right, this is for British Standard Thread. So we can do one thing over here is just make an approximate curve. And hatch this portion. So this indicates we have material here and the threads are formed onto the exterior surface, nothing but an external thread in the form of British Standard Thread. Okay, right? Right? Okay, this is for British Standard Thread. Right? So next we shall go to another thread type. Let us see. The other thread type. Let me insert that image so that you can see it. Just a second. 1 second. Okay, yeah. So let us see one more thread for today. Have to draw it. So I'll take this entire thing above. Right. So let me insert one more. So here we have now is the British Standard Thread. Don't need this, we'll keep it here. Okay, so now we have next is called as the American Standard Thread or the Seller's Thread. So what is happening in this Seller's Thread? The height is going to be 0.86 times the diameter of the, sorry, 0.86 times the pitch. Okay, and it's not going to have a very sharp crest or a curved crust. It is going to have a flat crust. See here, this straight line. Okay, and the angle between the sides or the flank of the V thread is going to be at 60 degrees. Okay, all other things remain the same as the British standard thread only. Okay, so here the height of the thread is going to vary, which is going to be 0.86 times the pitch. So let me draw one line. Yeah, let me draw it. Let me draw one straight line. Just draw one straight line here. Yeah, 0 degrees. Okay, and then if I want this particular thing, keep it here. If I calculate, it's going to be how much? 0.86 times the pitch. Okay, 0.86 into 50. Okay, how much will I get? I'll get 43 mm. 48, I'll get here 43 mm, which will be the height of the thread, and here 43 divided by 6, I will have, is it 6 or 8? Just a second. Sorry, h by 8, not h by 6. It's going to be h by 8. Okay, so here I will have somewhere around 5.375 mm. Okay. Write it here only. Cellulose threads. Okay. We will have these particular things. Okay. So these things we have to first calculate. Okay, so h is going to be at 43 mm. So offset the line by 43 mm. Okay. Then we will have a distance of 5.37 offset by 5.37 and 5, and this particular line similarly from here also. One vertical line from here. From here, if the total angle is 60 degrees, then we'll have to draw it at total angle flank to flank is 60 degrees. Then this one side will be 30 degrees. Okay, let me draw this line also. Okay, and mirror this. Okay, so on the top crust and crust will be a flat end. Will be a flat end. So what I can do is I can just go to this intersection point to here, right? And I'll just copy this feature, just move it. Okay, so that here also I will have alright, so let me split it up, split this line over here, then split this line here, split this line here, right? So let me darken it. Okay, split it here also, split it here, right? Okay, so 1, 2, 3, 4. All these things are going to be dark, right? Okay, so now what I'll do is, don't need this line. Okay, so now I can just copy and paste it. Right, so I'll just go to move, copy these features. Okay, go to move, hold it here, just sit. Right? Paste it correctly. Not required here. I can finish this. See, the angle of this should be 60 degrees. Okay, right. Now all I have to do is just fill it up. This is American Standard thread or sellers thread, right? Okay, right? So this is all we have to do it in thread forms, right? So we have seen 2 threads. We'll continue the remaining types of threads in the next class. Yes, any doubts? Any doubts? Anything you want me to repeat? Okay. Okay, so practice these drawings and upload it into the Google Classroom, right?